This is our Unit 7, Lesson 2, kind of going over trig ratios for angles from 0 to 360. And we're just going to start to tie things in. You will have I want to call it a project, but it's kind of like an extended investigation assignment, this unit. I really like. It helps develop the unit circle. Again, so I said I don't like you guys memorizing things. But the fact of the matter is, this right here, this section will help you have knowledge in terms of understanding what the questions on that investigation are asking. Okay, this is really kind of setting things up and showing relationship between circles and triangles, a Pythagorean theorem, radius versus a coordinate, and those type of things. Okay, so anyways, we're going to be using Pythagorean theorem quite a bit. So you guys are familiar with that, a squared plus b squared equals c squared. But it's actually going to be, in this case, we're going to use x squared plus y squared equals r squared, with r being the radius. Okay, because whenever you're doing those triangles, r is always the radius. It's a diagonal. Okay, so we'll be able to deal with that. We also know that r can never be negative because of the distance. Okay, so those are different things we are looking at. All right. All right, so it's example 1 here. Says sketch the rotation angle in standard position and calculate the exact distance from the origin to the given point. Where appropriate, write the answer in simplest mixed radical form. You need to pay attention today because that little term again comes back, exact value. Okay, we talked about that in Unit 1. That's where you do not put a decimal. Okay, that's where you leave it as a radical and break it down. Okay, so you need to make sure you do that appropriately. All right, so let's go do this here. So point -512. So we want to go ahead and make that. So -5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we're up here. That's where that dot is on the terminal arm. So that means that this is the terminal arm. So we're going to go down to here. Let's do a little bit different color here. So that means that we're looking at this spot here. So it wants us to figure out the distance to the origin. So essentially, it wants us to figure out this right here. Okay, well, we can make this a triangle, like so. Okay, and we use Pythagorean theorem. We know this distance is 12. This distance is -5. You can call it distance and just call it 5. And why does it not matter? Why is it? Well, you can't have a negative distance by saying if you do put a negative in, why does it not affect us in this case? Because you square it. Yeah, because you still get -5 squared is 25 and 5 squared is 25. So it won't really mess you up if you put a negative. Okay, so we're going to go -5 squared plus 12 squared equals r squared, or whatever this distance is squared. Okay, so that's going to be, sorry, that's a 5. 25 plus 144. 169, and then we're going to square root. So r is 13. We only write 13, not -13, because as it says above, r can only be positive. Okay. And we're just going to do point 2 now. So why don't you guys go ahead and try point 2 really quickly. I'll give you some time. I'm going to pause the video for a second. Okay, so point -2, -6, the first thing I want to do is I want to go ahead and put that just kind of on a grid just to kind of look at it. So I'm just, you do it by hand really quickly. So we got, okay, so we have -2, -6. So we're right there. So that gives me this terminal arm here, and I can make a triangle like so. Okay, whoops, I went a little bit too far there. Okay, and so again, we use Pythagorean theorem. You have -2, you have -6. So we're going to go -2 squared plus -6 squared equals our r squared again. So we get 4 plus 36, which is 40. And then we square root, and we need to work on breaking down 40. Okay, so we're going to get 40 breaks down to 4 times 10. Pull the 4 out, so r equals 2 root 10 is your exact value. That's your exact answer. Okay, any questions or concerns on that? Okay, let's go ahead and move forward here. All right, so we're going to talk about now trig ratios. This thing is really, where am I at now? Oh, wow. On the wrong page. Okay, so we're going to talk about trig ratios. So these are important in terms of kind of the SOHCAHTOA idea, understanding what it's referring to when it's saying what trig ratios are. So, for example, trig ratios come from, so here's the angle, the relationship of the angle in terms of the sine, cosine, or tangent. Okay, so like, for example, sine theta, if you look at SOHCAHTOA, that's your opposite over hypotenuse. So sine is this over this. So you would say opposite over hypotenuse. So these ones you should already know from Math 10. Cosine is adjacent, so next to, so this side over hypotenuse. And then tangent's opposite over adjacent. Opposite over adjacent. Okay, and that's what SOHCAHTOA stands for. So essentially what they are, an angle's in a right triangle, an angle's relationship with the angle and opposite of hypotenuse is a relationship of sine. Okay, and so they have a relationship in terms of, like, if you have 3 of the 4 things, like if I have the angle on one of the sides, I can find the other missing side. Or if I have the 2 sides, I can figure out what that angle is, etc. So the relationship in terms of, you can use this to like help you solve. Now, for our purpose in this unit, we want to recognize them actually in terms of x, y, and r. So we're going to use this triangle to help us develop these ratios for x, y, and r. So for that angle, what would sine be? What would sine be in terms of x, y, and r? Y over r, exactly. So sine would be y over r. And when you get to Math 30 and higher math, this is why we kind of relate sine to y because of that. Sine is y in our mind. Cosine is x in our mind because cosine is x over r. Okay? So cosine, we want to kind of link to x. Okay, and then tangent then is going to be y over x. Okay, these formulas will not be on the formula sheet. You should know these. Okay, so, and you can always kind of come to it by just looking at a coordinate grid, though, because it's not like a number or anything. It's a relationship that you can see if you know what you're looking at. Okay, so it says you should memorize it however you want to think about it. All right, so example 3. So it says, point 15.8 lies on the terminal arm of angle is shown. Calculate the value of r and determine the exact value of the primary trigonometric ratios. So it wants us to set up the trigonometric ratios for this set based on what we just learned. So the thing is that we don't know r, so we need to get r first. We're trying to figure out what sine theta is, which we know is y over r. We're trying to figure out what cosine theta, which is x over r, and then we're trying to figure out tan theta, which is y over x. We have x and y right now, we don't have r. So we're going to do a little work really quickly to get that. So it's 15 and 8 here. So 15 squared plus 8 squared is r squared. Okay, this is what we're going to be doing pretty consistently using our Pythagorean Theorem. 225 plus 64 equals r squared. 289 equals r squared. So r is 17. And now we have what we need for our trig ratios. Okay, so we would go, this is y 8 over 17, x 12 over 17, or 15, sorry. Okay, and then the last one would be 8 over 15. So those are our trig ratios for that given coordinate. Okay, any questions at all yet? Okay, keep on trucking here. All right, so then we're going to move to a little bit of investigation here. So we're going to look at investigating trig ratios for angles between 90 and 360. And this is where it's going to really tie in. So if you want to start this page or just remember this is going to tie into that assignment that I'm going to give you tomorrow that I'm talking about, okay, for developing the unit circle, because it gives you the relationship. Because if I'm saying right now, I just said I want you to associate sine with what value? With y. And if I want you to associate cosine with x, then that's kind of also, we're going to think of those as coordinates. So if I'm asking you for the sine, I'm asking you for the y. I'm asking for the cosine, I'm asking for the x on these ratios. Okay, and the x is just a lateral movement, and the y is just a vertical movement. Okay, but again, I'm giving you a little bit too much right now, but we'll just keep going. So consider the angle theta in standard position with the point 1 root 3 on the terminal arm. Show the value of theta is 60 degrees. Show the value of theta is 60 degrees. So what we're going to do is, we know, like I just told you, we know that x is 1, y is root 3. That's what we know. Okay, and so we're going to go, we know, so if you just have x and y, what trig ratio do we have enough that we can use? Tan, good, we can use tangent. We can use y over x. So if I go tan theta equals root 3 over 1, well, that's just root 3, right? Tan theta equals root 3. What are we going to do now? Like, how do you guys know how to solve for theta there? Yeah, tan inverse was called. She said negative tan, but it's in your calculator. If you look at your tangent button, the second function of it's the tan inverse. So we're going to do tan inverse to both sides. Whoops. Root 3 there. And that's going to kick out what your angle is. So everybody please try that really quickly. I'll pause the video, but go ahead and try that. Or I won't pause it because I don't want to lose the writing. Okay, so you're going to hit second tan, and you're going to put root 3 in there. And you should kick out 60. Okay. Yep. Good. Okay. Everybody see that? So that's how we figure out what this angle measure is. So this angle measure is 60 degrees. Okay. What's that? Make sure you're in degree mode. Go to mode and make sure you're in degree mode, not radian. Yeah, probably in radians. Why? Okay, now we're going to calculate the value of r. If you're still having trouble with that, I'll come around later. It's probably just a mode issue. Okay, so we're going to calculate the value of r by quickly doing Pythagorean Theorem. So I'm just going to do that up here, okay? So I'm going to go 1 squared plus root 3 squared equals r squared. 1 squared is 1. What's root 3 squared? 3, right? It just goes away. So I get 4 equals r squared, so r is 2. So we get r is 2. Complete the following using x, y, and r. So we know x is 1. We know y is root 3, and r is 2. So sine of 60 is equal to, okay, sine of 60 is equal to y over r, which y over r would be root 3 over 2. Cosine, I'm on the wrong page, or there we go. Cosine of 60 is x over r, that's 1/2. And tan is going to be root 3 over 1, which is just root 3. So that's its rotation. So now what we're going to do is we're going to take that same point and we're going to put it into quadrant 2, and we're going to see what happens to these values in terms of positive, negative. Okay? So knowing, like, if just let's take an educated guess, if I'm in quadrant 1, everything's positive, right? If I'm in quadrant 2, what's negative? X's. So anything with an X is now going to be negative. So we're expecting this will be negative, and we're expecting this to be negative. See, they have x's, so now it'll be negative values instead of positive, but we'll get to that right now. Is everybody still okay? I know these are ugly numbers, but I think trust the patterns. That's what the best thing I can say, I think. Okay, so look at part 2 here. So rotation angle in part 1 is reflected in the y-axis. Okay, so what that means now, the old point, which was 1 root 3, is now negative 1 root 3. So if we reflected it, our reference angle for the first one was 60, right? Because it was 60, but that was also the reference angle, because in quadrant 1, the reference angle is the same as the rotation, right? So then this one has the same reference angle of 60 now, because we just reflected it. So that's also 60. So if that's 60, what is the rotation angle? Let's see if you guys know what you were doing yesterday. 120, good. These two have to add up to 180. Why? Because this whole thing's a half a turn, which is 180, 60 of it, 120 of it. Okay, so now we're going to set up our ratios. Sine of 120 is y over r. So in this case, that's still going to be root 3 over 2. Everything is positive for that because y and r stayed positive. But now we run into our negatives. It's a negative 1 over 2 because I'm negative 1. And this is going to be root 3 over negative 1, which is just negative root 3. So you can see how the points are kind of flip-flopping signs for certain ratios. We're kind of developing a rule, if you're wondering. Okay, so what we just figured out so far is we figured out that in this one, everything was positive, right? In this one, everything's negative except for sine. These two are negative. Okay? All right, so now confirm these trigonometry with your calculator. So in your calculator, what you can do is you can do sine of 120. It'll give you a decimal. And then you can do this, and it'll be the same decimal. They're equivalent. Okay? They're equivalent ratios. All right, so we're going to do part 3 now. You can check those later if you'd like. All right, so part 3. We're in part 1 here. From part 1, I mean. So it's reflected by the x-axis now. So we went reflect, reflect. So now we're in quadrant 3. So the point is now going to be negative 1, negative root 3, right? Because this is negative x and negative y, so they're both negative. The reference angle is still 60. What's the rotation this time? Exactly, 180 plus the 60, so 240. Okay, seeing that? The half that turns 180, and I went 60 more. So sine of 240 is y over r. Sine of 240 is going to be a negative root 3 over 2. Because the y is negative over the 2 for r. And then it's going to be a negative 1 over 2, because x is negative over 2. And then for y over x, it's going to be a negative root 3 over a negative 1, which is a positive root 3. So tangent ended up being positive because it's a negative over negative. Okay? So what we figured out so far now is we're developing a rule. Like I said, the first one we did, everything was positive. The second one we did, only sine was positive. The third one we did, only tangent was positive. Okay? So which one hasn't been positive by itself yet? We did all sine, tangent. Cos. So we're probably going to see cos be positive next for the last one. Okay? So let's look at these. Last one. Okay, so again, we reflected it one more time. So this time we're going to have a 1 and a negative root 3. The reference angle is still 60. Okay, what's the rotation angle? What's that? 300, correct. This is 360 minus 60, 300. Okay, so here's the ratios. Y over r. Negative root 3 over 2. We're still negative for y, which makes sense because we're below the x-axis. Cosine is positive, so it's 1 over 2. And then tangent's going to be negative because of the y is negative. So again, like we said, cosine was the only thing positive in that section. Okay, so the observations is the trigonomic ratios for angles between 90 and 360 are either trigonomic ratios of the reference angle or negative of the trigonomic ratios of the reference angle. So it's going to be a positive or negative relationship is all it's saying. Okay, and that's what we've gotten. We got 1/2 for every section, right, for cosine, but it was just changing between positive versus negative. Now, I said associate cosine with which letter? Okay, we got to know that, guys. I'm saying basic stuff. X. Cosines with X. Got to absorb some things, okay? Cosines with X. So if I'm saying cosines with X, which quadrants, 1, 2, 3, and 4, is cosine positive in? 1 and 4. If you go look at that we just did, in our sections 1 and 4 is where they were positive. Same thing for sine. Sine y is what we're thinking about. These two quadrants, it's going to be negative, right? Because I'm below the x-axis. That's the relationship I'm trying to get you to understand right now. It's the relationship between sine and cosine and x and y and where what is positive and negative. Okay? All right, so that's essentially what this observation is saying. Okay. All right, so determine the sine. So in order to determine the sine, this is kind of just repeating what we just did. I'll go through it a little bit quicker so we don't get too bored with it here. But so sine, we know sine is y over r. We're just rewriting our ratios here. X over r, y over x. So we're just having this. You can write these on all of them if you want for good practice of remembering your ratios. Okay, so what you're going to do is you're going to say, in this quadrant, what is it? So we'll start with quadrant 1, because that's the easy one. X is positive, R is always positive. So it's positive or positive, which is positive. Y is positive, and X is positive. So this is our all positive section. So here, sine, Y is positive in quadrant 2. R is positive. Cosine, my x is what? Negative. So that's negative, and then I have a positive over a negative, so that's negative. So again, sine is the only one positive. This one was all. Okay, for quadrant 3, y is negative, r is still positive. X is negative, r is positive. And then y and x are both negative. I know that looks like wow, that was horrible. Try to do a little bit better there. So we got our bar, and a negative over negative is a positive. So tangent, so t was positive here. And lastly, quadrant 4, y is negative over positive r, which is negative. Cos is positive over positive, and y is negative over positive. So this one, C, is positive. What we've just done, okay, and you'll see on the next page, we developed the cast rule. Cast, C-A-S-T. What those letters represent is which trig ratio is positive. So C, cosine's positive. Everything else is negative. A, all. S, sine. T, tangent. Okay, you just developed the cast rule. Okay, so if I said, I should be able to say cosine of 240, is that positive or negative? And you should be able to tell me without needing a calculator or anything. Okay, what I mean by that is cosine 240, what quadrant am I in? 3. What's positive there? So cosine B, negative. That's it. If I said sine of 308, over here, what's positive in this section? Cosine. So sine is negative. Okay, so you're figuring out the signs for those ratios in their given degree measure. Okay? All right, Good, good, good. You guys are acting like it's Monday. All right, so to finish these out here, sign ratios have positive values in quadrants. So where is sign positive? So sign is positive in 1. Whoops, all right, highlighter. So sign's positive in 1, and which one? CAS2. Sign's positive in 1 and 2. Cosine is positive and also in 1 and then 4. Tangents 1 and 3. Sine's negative in 3 and 4, which makes sense because 3 and 4 is below the x-axis. Cosine's negative in 2 and 3. It makes sense. It's left of the y-axis, negatives. Okay, and then tangents negative in 4, 2 and 4. So that, again, we developed the cast rule. Okay, I've always learned at cast. If you want to try the add sugar to coffee, whatever you feel like doing. Okay. Okay. Good deal. So that's what we're going to do right here. So I just told you we're going to do these out loud, like kind of out loud. So let's just go around here. Let's Army, sine of 340. What do you think, bud? Is that going to be a positive or negative? Correct. Okay, so 340 is in quadrant 4. Quadrant 4 is a C. Okay, therefore that means it's a C, so cosine's positive, everything else is negative. Okay, Joe, so you want to try 227? Okay, so where's 227 at in terms of our rotation angle? So 227 is going to be in here, right? So then tangent here, CAST, positive. Okay, because it's tangent, right? So this one's going to be negative. This one's going to be positive. Okay, we'll keep coming across. Maddie, what do you think about sine of 88? Positive, right? 88 is right here. It's in the positive everywhere. Okay, so good. Okay, Wiley, what do you think about cos of 235? Negative. Let's see. I assume you're right. 235 is in here. Tangent's positive, so yes, negative. Good job. We'll go across some more. Spencer? Cos of 308. Good. Cos of 3/8 in this section. That's the C section. Okay. That's positive. Tan of 123, Xander, what do you think? Negative. Good, because tangent's in the 123. That's right here. Now, if I just blew through these and you have no idea what I'm talking about because you don't know where I'm going with these degree measures, let's take a second and make sure that we know the basics. The basics of understanding is that we need to know this is 0 degrees all the way around 360. So this is a circle essentially. Okay? This marker is 90. This marker is 180. This is lesson 1 stuff, and this is 270. So if you're saying how do you know what quadrant you're in, well, 123 is between 90 and 180. I know I'm in here. If I'm in there, that says sine's supposed to be positive. Everything else is negative. That's the other, so that's negative. That's how I'm finding these things. I'm not just rattling them off. Okay, it's not some weird mental math. Okay, we can all figure out where we're going to be. Okay? All right. We're on the downward decline here. Okay, so trig ratios, reference angle. Okay, so the trigonometric ratios for any angle are either trigonometric ratios of the reference angle or negative. So that's what we talked about earlier, just understanding that it's either going to be a positive or negative of it. Okay, let's actually get to the examples of it. Last thing here. Okay, so it says rewrite the same trigonometric function as an acute angle. So it means this, what's an acute angle? Let's go with that. Less than 90. So when we write it with something less than 90. So 140, this is what we have to do, and you're going to have to use reference angle. That's what it's talking about. So if I draw this, 140 is right about here, correct? This is about 140-ish. Okay, what's that reference angle? 40. That's what that reference angle is. Does everybody understand that? 140 plus 40 is 180. Okay, so I know my reference angle is 40. So this is what I'm going to ask you. Is sine with x or with y? Y. Okay, we got to be yelling that by now. Sine, we're thinking with y. Is sine positive or negative in 1 and 2? Positive. It's above, correct? So do we understand that sine of 40 is equivalent to sine of 140? So sine of 40 is going to have the same exact value as sine of 140 because it's over here. They're both the same sine because they have the same reference angle. Okay, so let's go back. I know I'm probably saying a little too much. Okay, so when we did it earlier and we were doing the reflecting, remember, we reflected all over the axes. Remember, those points are the same and they have the same reference angle. So if I reflect over, I have the same reference angle. So 40 and 140 are a reflection. So they're the same point. So this point, whatever this would be, those are going to be the same points but reflected. So if this, I'm just making this up, if this was 3, 2, this is negative 3, 2. But the point is, we only care about the 2 because that's the y. To write this with that degree measure acute, I need less than 140. So since they're the same, I'm going to write it with 40. Okay? So right now, I want you to prove it to yourself. I want you to do sine of 40 in your calculator and sine of 140, and you'll see the values match up. Okay, so please do that. Yep. Yeah. Not inverse, just regular sine, okay. Just regular sine, not inverse. Okay. Well, we're going to do 6 of them, so if you're still a little foggy, we're going to do 6. We'll figure it out. Okay, so tan of 323. So we got to figure out where that is. Tan of 323 is over here. Okay, we want it to, so in that section, is tan positive or negative? It's negative. Where else is tan negative? Yeah, over here. We need this one. Okay, so I'm explaining. Draw a little bigger here so we can see it. So 323 is about right here. That's about 323. We need to figure out what this reference angle is. And we know this is a negative for tangent. We want the other spot that's negative for tangent. That's positive for tangent, and that's positive, so it's got to be up here. So we want this same reference angle. So this angle and this angle should be the same. So what is that reference angle? What's that? 310? 37, sorry. 37. Okay, here's the catch though. This is where people run into mental blocks. So it's 37, we're all comfortable with that, right? So, but it says it wants it to be written as an acute angle. So if I do 180 minus 37, what will that be? It'd be, what was it, like 143? Yeah? Is 143 acute? No, so then what do I do? How can I write it so it's equivalent but with an acute angle? What's that? To the closest x, what do you mean by that? You might be on track. X to the left. Oh, I see what you're saying. No, not quite. I see what you're saying. Well, we actually want this angle, right? We want the 37. So I'm going to write tan of 37, but that's going to be positive, right? So how can I change it? Put a negative in front. Okay, so try that real quick. So all I've done is I've wrote acute. I know it's supposed to be negative, so I put a negative out in front. That's all I did. So we're going to come back to that quadrant 1, okay, every time, but we're going to put a negative or positive in front, essentially, so I'm kind of getting to the point. Okay, so if you put tan of 323 and you put negative tan of 37 in your calculator, you'll get the same value. Let's try a couple more. Like I said, we have 4 more. All right, cos of 165. So I'm right here. 165. Cos over here, cos goes with x, so it's currently negative. It's 15 degrees for the reference angle. So since it's negative, I'm going to go cos 15 with a negative. So you're seeing the pattern now where essentially we're just finding the reference angle and we're just making it negative if we have to, and we're not if we don't have to. That's all we're doing. 287, so that's past 270, so that's going to be right about here. Okay, so that's going to be 13 plus 60, so 73 degrees is that reference angle. Is sign positive or negative down there? Is sign positive or negative here? Negative, right? A couple ways to think about it. Casserole, it's a C, or sign's a Y, and we're below. Okay, two ways. So we're going to go negative sign 73. Okay. Cos of 308. 308's right here. Again, we're in quadrant 4, but this is the C quadrant, so it's positive there. Okay, so we're good with that. Let's figure out what this reference angle is. That reference angle would be 52, 52 degrees. So we just want simply cos of 52. We don't have to put a negative because it's in the positive section. And last but not least, tangent of 199. Again, that puts us in the third quadrant. Which quadrant is this? C, A, S, or T? T, so therefore it's positive, right? Okay, the reference angle is 19 degrees, 199 minus 180. So we just want tangent of 19. That's it. Okay. And below there is just a list of the different patterns of things we've been talking about. For those of you guys trying to ask, when do I subtract from 360 or add 360 or 180 for the reference angles? That's kind of right below. You can look at that if you'd like. Okay, we are done.